In the tradition of past explorers like Magellan, Columbus, and Marco Polo, we embark on a new frontier. For thousands of years, we've looked up into the night sky and wondered about the bright red light that stands out from the rest. Over the years, our curiosity has only grown stronger. Now that we're capable of space travel, man's spirit dictates that we must go. As we did with the moon, we must experience it firsthand. Since 1960, there have been 50 unmanned missions to the Red Planet. About half have failed, yet we keep trying. The first spacecraft to successfully orbit Mars was Mariner 9 in 1971, which did extensive mapping of the Martian surface. In 1976, Viking 1 and 2 were the first spacecraft to land on the surface of Mars. In 2001, the Mars Odyssey mission was the first to detect large amounts of subsurface ice. That and other missions in the early 2000s showed us that past life on Mars was a distinct possibility. Efforts are currently underway by NASA and others, such as Elon Musk's SpaceX, to send a manned mission to Mars by 2035, traveling more than 250 million miles each way. With the possibility of past life on Mars, it's intriguing to think about what we might find there when we finally arrive. Because it takes so long to get there, we must plan on extended stays. Bases will be established and stocked with supplies to keep the astronaut explorers alive for months. However, long-duration missions can't rely on constant resupply. Transporting everything from Earth is too heavy, too slow, and too expensive. Local resources such as water, CO2, and elements found in the Martian soil will be leveraged. If Mars once supported flowing water and an atmosphere, could the conditions that allowed this be recreated? The process for doing this is known as terraforming. Although the challenges are significant, the benefits are many. A second home for humanity would allow us to expand our reach in the universe. The experience that would be gained by establishing a presence on another planet would be invaluable to protect our future. Scientists say that our sun is at the halfway point in its life. We can expect it to burn out in about 5 billion years. But even before that point, life on Earth would become more and more difficult. Before it finally burns out, it will get increasingly hot, allowing our oceans to boil off in about 1 billion years. Although this seems like a long time away, the knowledge and technology that will be required to escape is enormous. The sooner we begin, the better chance we have for survival. It's intriguing to consider that this may have already happened in the past. Considering that the universe is almost 14 billion years old, it's conceivable that other civilizations in other solar systems have already dealt with this same situation. Many believe that there are signs here on Earth that suggest other civilizations have visited, if not established a presence on this planet in the past. One of the problems that must eventually be solved is the length of time it takes to go to Mars and back. We must look to new ways of transporting ourselves through space. Currently, we leverage chemical propulsion methods. Chemical rockets are powerful, but inefficient. They provide a tremendous push at launch and during course corrections, but they can't sustain thrust for long periods. We rely on this push to counter the effects of Earth's gravitational pull. After that initial push, we rely on the inertia for most of the trip and leverage Mars's weaker gravitational pull for the rest of the trip. Using this method, it takes 7 to 9 months to get there. One new technology currently under development is nuclear thermal propulsion, or NTP. NTP heats hydrogen using a nuclear reactor and expels it as thrust. This technology offers 2 to 3 times greater efficiency, cutting a trip to Mars by roughly half. Instead of 7 to 9 months, it would take 3 to 4 months. Some researchers suggest even as low as 45 days. Another technology being proposed is nuclear electric propulsion, or NEP. NEP uses a nuclear reactor to power high-efficiency electric thrusters. This propulsion system would be highly efficient and could shorten the trip to between 2 and 4 months. However, this is only a concept and not currently under development. But what if we could refill the rocket motor's propellant along the way? Instead of one initial burn and the mid-course correction burn, by recharging the propellant, we could increase the rocket's inertia using successive burns. Using a nuclear thermal propulsion system, the reactor core would only need to be filled with enriched uranium when initially built or during major maintenance. The propellant, in this case hydrogen, would be the only thing that would need to be refilled. Filling stations strategically placed along the path to Mars would allow the hydrogen to be refilled. The filling stations can be designed to create their own hydrogen using resources found nearby. They can be completely autonomous and use either nuclear or solar energy. They would generate hydrogen as well as oxygen for life support. It's conceivable that technology can be developed to collect hydrogen and oxygen from space using electromagnetic scoops. Hydrogen in the solar wind is ionized, so it can be manipulated with magnetic fields. By using the refueling station architecture, along with the currently being developed nuclear thermal propulsion technology, we can burn harder both outbound and inbound and avoid carrying all the propellant from Earth. Scooping hydrogen using electromagnetism will help supplement the hydrogen derived from lunar, Martian, and asteroid water. Speeding up the time it takes to get to Mars and back will reduce the amount of radiation astronauts will have to endure. It will also reduce stress and allow for more time on Mars. Perhaps one day we will master the art of gravitational transport, an art that may have been lost to time. Until then, we must learn to make what we know how to do as efficient as possible.